So we're Group 2 from the 3A System Design Engineering class. My name is Daniel Aritza. I'm also working with Stephen Hayes, Zach Goldstein, Majd Al-Shahabi, and Nolan Finkelstein. What we've created is an energy-generating stadium chair. So we're really interested in the experience of people when they go to stadiums in order to have a good time. And we also saw that people kind of feel not really engaged all the time. Also, there's a lot of electricity use in stadiums, $30,000 to $40,000 a month. And we said, hey, can we design something that gets people, riled up and full of emotional energy, and also harnesses that energy into electrical energy and put those things together. And what we created was a chair that harnesses your energy.
So this is our prototype, and the main component is this central column here, where we have a magnet, and in this pipe we have wrapped around it a lot of coils of wire. So when the magnet moves up and down, it passes through the coils and actually generates electricity. And as you can see on the oscilloscope here, if I sit down on the chair, we get a spike of energy, and when I sit back up, the chair is restored to its regular state, and we get another increase of energy. And that's because we have springs in here that cause it to reset to its normal height.
Cool. So we've really paid attention to the ergonomics of this to make sure that it's dimensioned in the correct way so that someone who's short or someone who's tall will still feel comfortable with a chair that moves up and down. It's very interesting. So the three main advantages of this device is that, one, it's novel and it'll probably attract people to the stadium to try it out. Two, that it is generating electrical clean energy, not from fossil fuels, but from humans. And thirdly, that it can also create a fan engagement when people get up and sit back down and on their feet and are riled up.
So the first question we wanted to answer with this chair was, how much energy can we actually generate? And so from some basic calculations, we found that there was about 600 joules to be captured from a single person sitting down. And if we multiply that out by 40,000 people in a stadium, a 3-hour game, and assume they sit down twice an hour, which is a pretty conservative estimate for baseball, then we'll find that they generate about 6,000 watts over the course during a game. And that's only if we use the conservative estimate of 2. We've looked at doing some crowd engagement stuff where we encourage them to jump up and down more, like get them to do the wave and stand up and sit down. And we think that if we do that, we can actually increase it to sitting down about 6 times an hour, which will make them generate 18,000 watts.
So we've learned a lot building this, and we've had such a really good experience in learning to go from the beginning stages of what our customer needs, having more fan engagement and also reducing the electricity bill, and we've created something real that we're pretty proud of. We hope that one day you'll see this in a stadium, powering perhaps a jumbotron or televisions or visualizing you doing the wave. Thanks.